right, to introduce the three types of skeletal muscle, I want you to sort of remember back to those days of long, long ago when you went out on your first date, right? So imagine you as this person here, right? All dressed up, snazzed up, getting ready, waiting for your transportation to meet the person of your current dreams. Right? As you're standing here, right, leaning up against this wall, putting your hands in your pockets, supporting the weight of your head, you're using skeletal muscle, right? This is the primary muscle of our limbs and core that holds us up and lets us move around, right? And as you're sitting here, or standing here, sorry, thinking about this dream person, your heart might start to beat a little bit faster, right? And that's going to be caused by the involuntary contraction. So you have no real control over this. This is controlled by the parasympathetic and sympathetic nervous system, which is also tied to your hormones. So as your nervousness rises, your heart rate may also begin to rise. And with this, you may also start to get a little bit nervous and get some butterflies in your stomach, right? Your stomach might start to feel a little weird and maybe churn a little bit. And the muscle of the stomach, as well as the entire digestive system, is smooth muscle, which is also under involuntary control, right? So the three types of muscle. So you have skeletal muscle used in supporting and moving your limbs and core of the body. You have cardiac muscle in the heart, and you have smooth muscle of the digestive system and vasculature. All right. So now we're going to go into each of those a little bit more and talk about their ultrastructure. Right. So here is a figure overviewing skeletal muscle or striated muscle. Remember, this is the muscle of voluntary control that we use to support our bodies and move us around. So this starts out as a series of cells called myoblasts, and then those cells are going to fuse for the most part and become a multinucleated, striated, so it has definitive structure, which we'll see later, muscle fiber, right? And then some of those cells that choose not to fuse will become satellite cells, and we'll talk about that a little bit later as well, right? So skeletal muscle under voluntary control, multinucleated, has a definitive striated pattern or banding pattern. Okay, and then we're going to go on to cardiac muscle. So cardiac muscle, muscle of the heart, right, also has that striated pattern like we saw in the skeletal muscle. Right. Big differences are this is under involuntary control, unlike the skeletal muscle, which was under voluntary control, and it has these intercalated discs, right, which is connecting one cardiomyocyte to another cardiomyocyte. So these here, the cells did not fuse together into one long multinucleated cell. They stayed individual cells, but they are directly connected through these intercalated discs, which is a combination of desmosomes and gap junctions, right? And then lastly, we have smooth muscle, right? Smooth muscle looks like a whole bunch of single cells, and exactly like the single cells, right? It doesn't have a Y shape, it doesn't have a cylindrical shape. It sort of has that blobby shape that we sort of love and endear to all of our cells, right? And inside of the smooth muscle, there's not a banding pattern, and we have the same contractile apparatus. We have actin-myosin, and it's ordered in a slightly different way, right? And this again is under involuntary control, so this is under the control of the autonomic, which is the somatic, or the autonomic is under the parasympathetic or sympathetic nervous system, right? So just to summarize, here's the three types of muscle. So we got skeletal, cardiac, and smooth. Skeletal and cardiac are both striated. Smooth is not striated, so there's not that banding pattern in the smooth muscle that we see in the other two. In terms of nucleuses, or the number of cells that make up a single muscle cell for each of these types, skeletal muscle has multiple, right? Cardiac and smooth are single. The innervation, so the skeletal is under voluntary control, so we have direct control over our skeletal muscle, and the cardiac and smooth is under involuntary control, so we do not have direct control of that, right? And then lastly, I just wanted to talk briefly about the activation kinetics, and calcium is going to be our big activator here. For both skeletal and cardiac, calcium is going to bind to troponin to cause the muscle to activate and contract. And for smooth muscle, it's a completely different mechanism, and it's going to go through calmodulin. So that's all I have for you today. Hopefully you found this useful, and we'll see you soon.